All right, we're going to pick up where we left off, calculating gram molecular mass. We're going to do this for CH3OH. First things first, carbons, hydrogens, oxygens. I've got 1 carbon, 4 hydrogens, 1 oxygen. I'm going to multiply it by the mass on the periodic table. I'm rounding to the nearest hundredth. So for carbon, it's 12.01. For hydrogen, 1.01. For oxygen, 16.00. When you multiply those out, you get 12.01, 4.04, 16.00. You want to add those up and get a total, 32.05 grams. This is your GMM, gram molecular mass, of this molecular compound. Gram formula mass is when we have the mass of an ionic compound. The calculation is the exact same, but we're looking at something that has a metal and a nonmetal like we talked about yesterday. So what is the GFM of magnesium phosphate? Well, mg's, you've got 3 phosphorus, you have 2, and oxygen, you have 8. Remember that this 2 distributes, just like in math, across the parentheses. We multiply those together. We're going to multiply the mass, 24.31. Phosphorus is 30.97, and 16.00 grams for oxygen. These are all grams. Final numbers, 72.93 grams, 61.94 grams, 128.00 grams. Final mass, 262.87 grams. This is your GFM, not GMM, of this ionic compound, magnesium phosphate. So, terminology, gram atomic mass used for atoms. When we're looking for the mass of zinc, that would just be for, we call that GAM for short, gram atomic mass. Gram molecular mass is for molecular compounds when we have nonmetals. GFM is when we have ionic compounds. Otherwise, it's all the same. You're adding up the masses. So let's do it for ammonium sulfate, which is NH4 2 SO4. Here we go. Nitrogen, hydrogen, sulfur, oxygen. We have 2 nitrogens, 8 hydrogens, 1 sulfur, 4 oxygens. Nitrogen is 14.01, hydrogen 1.01, sulfur 32.07, and oxygen 16.00. Masses 28.02 grams, 8.08 grams, 32.07 grams, 64.00 grams. Add them all up, molar mass 132.17. So overall, you might hear me say this 100 times. Molar mass kind of covers it all. Whether it's a molecule, formula unit, atom, you name it, molar mass covers it. Okay, we're going to move on to converting using molar mass. This is going to be our second conversion factor. I'm going to put a puffy cloud of greatness around this. For every 1 mole of a substance, you have a GFM, or, we're going to call it a molar mass. You have to calculate it. It's not a given number. You're going to have to figure this out every single time. So let's find the mass in grams of 3.32 moles of potassium. I start out with 3.32 moles of potassium. For every 1 mole of potassium, I have 39.10 grams of potassium. Well, where did this come from? You're going to look on the periodic table and calculate. Remember, this is our molar mass conversion. So when we calculate this, our final answer is 1.30 times 10 to the second grams of potassium. We have used molar mass as a conversion factor. This is our final answer. In number 11, we're finding the mass in grams of 15 moles of sulfuric acid. The formula is H2SO4. All acids start with hydrogen. Hydrogen, sulfur, oxygen. We need a molar mass if we're going to hope to convert moles into grams or grams into moles. I have 2 hydrogens, 1 sulfur, 4 oxygens. The mass of hydrogen, 1.01. Mass of sulfur, 32.07. Mass of oxygen, 16.00. 2.02 grams, 32.07 grams, and 64.00 grams. Our molar mass, our conversion we're going to use is 98.09 grams. And our conversion is grams per 1 mole. That's how we're going to use it here. So let's convert. I'm starting with 15.0 moles of H2SO4. For every 1 mole of H2SO4, I have 98.09 grams of H2SO4. When I calculate, final answer, 1,470 grams H2SO4. Number 12, find the number of moles in 187 grams of aluminum. So here we're just looking at a single atom. 187 grams of aluminum. I like this problem. I look on the periodic table, 26.98 grams of aluminum for every 1 mole of aluminum. Final answer, when I divide, 6.93 moles of aluminum. And we're going to finish here with number 13. Find the number of moles in 11 grams of methane. So we're going to need to find molar mass here. Carbon, hydrogen. We have 1 carbon, 4 hydrogens, 12.01 for carbon, and 1.01 for hydrogen. So 12.01, 4.04 grams. Our molar mass here is going to be 16.05 grams of methane. So let's convert. 11 grams of methane. For every 16.05 grams of methane, we have 1 mole of methane. When we calculate, final answer, 0.685 moles of CH4. Okay, we're going to go ahead and stop there. Thank you so much.